In the last video, we saw that you can create a polar equation for a circle centered at 0, 0, for a line passing through 0, 0, for a vertical line, and for a horizontal line. And for the circle, the equation was actually more simple in polar because it was like r equals 5 or something like that. But for the other three, well, especially for the vertical and horizontal line, the equation of that line in polar was actually more complicated than the equation for that same shape in rectangular. Today I'm going to show you on this video, start with an equation that looks pretty complicated. R equals 4 over cosine theta minus 30. And since we don't have a feel yet for what this might be, even though the points are graphed r comma theta, our chart is going to have theta on the left, 30. Cosine of 30 minus 30 is cosine of 0, which is 1, so r would become 4. So I have at least this one point at 4, 30 degrees, somewhere, 1, 2, 3, somewhere over here. There are certain undefined things, like if I put 120 in, cosine of 90 is 0, and cosine of 270 is also 0. So if I put 120 or 300 in, I'm going to get undefined. If I put 210 in, I get cosine of 180. Cosine of 180 is negative 1, so that would become negative 4. But 210, negative 4 is actually the same point over here. One more I'll put in is 90, because if you put 90 in, you get 4 over cosine 60. Cosine 60 is 1/2, so you get 8. So 90 up here. Now it turns out that if you do find more points, they will all end up on this line here. So this is a line. This thing is also the equation of a line, but it's not a line, not a vertical line or a horizontal line, but it's a line that's not passing through 0, 0. And I'm going to show you how we could see what this line is and kind of predict it. So let's take the equation. R equals 4 over cosine theta minus 30. If I cross multiply, I get r cosine theta minus 30 equals 4. Now I could, the only thing I can do really is expand this with the cosine a minus b formula. Cosine theta, cosine 30. Put this whole thing in brackets. Sine theta, sine 30. So this is getting pretty ugly. It becomes it becomes r cosine theta. Cosine of 30 is radical 3 over 2. I don't know why I wrote 5 here. I meant r. R sine theta. Sine 30 is 1/2. Now r cosine theta from the last lecture could be replaced with x, and r sine theta can be replaced with y. And eventually this turns into y equals square root of 3x plus 8, which agrees with this picture. But what I want to show you how to do, and this is more complicated, how to go backwards if I have the graph already. So I'm going to take you through that process now. Let me just erase all this. Okay, so one point that's really important for us to have is the point 4, 30 degrees. I'm going to actually give you that point. So that point is on the line. And also really important, that's not just any point, that's actually not a random point. That's the point where if I made a line from 0, 0 and connected to that point, it would make a right angle. So what's given here is a line, and the coordinates of the points on that line, so that the 0, 0 line segment connecting 0, 0 to that point would be perpendicular to the line itself. So this seems like real specific, but that's how this would work. That is our given information, and from that, we're able to find the polar equation of this graph. And the way it works is, this is like a kind of process we did in the last video. You pick a random point on the line, and you call it r comma theta. Then if you connect from 0, 0 to there, we can now call this line segment r. And this segment here, this short one, that's length 4, because if this is point 4, 30 degrees. Now, theta, the angle, goes all the way from here to here. But if I just go from here to the line, that's 30 degrees. So this angle here is theta minus 30. And we're trying to find a relationship between r and theta, and this is going to allow us to do it. If I take this triangle here and kind of just put it sideways for a second, I have theta, r, 4, and theta minus 30. So and it's a right triangle. So the relationship here, the 4 is the adjacent side, so I would say cosine of theta minus 30 is equal to adjacent, which is 4, over hypotenuse, which is r, multiply both sides by r. 4 cosine theta minus 30 equals 4, and finally r equals 4 over cosine theta minus 30. So that's how you could have come up with that equation for this line. On the other hand, if you see an equation of this form, you can kind of take this number and graph that point 4 comma 30 degrees, and then just make a perpendicular, make a sort of radius here from 0, 0 to that point, and the perpendicular line will be your answer. So that's our first new shape. That's a line not passing through 0, 0, where the point closest to 0, 0 is given to us. Okay, the next shape I want to look at, first we'll look at the equation. The next equation I want to look at is the equation r equals 4 sine theta. This isn't like before, 4 equals r sine theta, where we could replace r sine theta with y. This is different. R equals 4 times sine theta. And if I want to get a feel for what this might look like, I'd get 0, sine 0 is 0, sine of 90 is 1, so that would be 4. Sine of 180 is 0, which gets us back to 0. Sine of 270 is negative 1, so that gets us to negative 4. If I just plot those points, it's not going to be that useful. 0, 0, 94, 180 is back here, and 274. So all I have are these 2 points. If I throw 2 other things here, like 30 and 60, it kind of gets interesting. Sine of 30 is 1/2, so 4 times 1/2 is 2. So I'd have this point at 30, comma 2. And 60, well, 60 is radical 3 over 2 times 4 is 2 radical 3, which is about 3.4. So now I have a point somewhere over here. It turns out that this would form a circle, but not a circle centered at 0, 0, but a circle that passes through 0, 0, whose center is on the, kind of like the y-axis, although it's the y-axis is called the theta equals 90 line in this kind of geometry. Okay, let me show you how we could have, if we had the equation r equals 4 sine theta, how we could have seen that would be a circle. Now, this doesn't look like, we had the relationships from the last lesson that are useful. These come in handy. R squared equals x squared plus y squared. This is r x y. Tan theta equals absolute value of y over absolute value of x. X equals r, here's theta, r cosine theta, y equals r sine theta. So none of those things really appear here. But if I multiply both sides by r, see, that's going to be really good because this r sine theta is here. So then I could replace that with x. And while I'm at it, the r squared can be replaced with x squared plus y squared. So now I get x squared plus y squared equals 4x. And that is the equation of a circle. If I want to go further with it, I can go x squared minus 4x plus y squared equals 0. X, I'll add 4 to both sides to complete the square. X minus 2 squared plus y squared equals 4. And that would be a circle with center at 0. Hold on. Oops, realize I made a mistake. R sine theta is y, not x. So this is a y. I still want to add 4 to both sides, but now it would be x squared plus y minus 2 squared equals 4, which is exactly that circle with center at 0, 2 and radius 2. It's that circle again. So that's how we could have gone from the polar equation into the rectangular equation. We could go in the other direction also. If I have x squared plus y minus 2 squared equals 4, I could change the x to r cosine theta and change the y to r sine theta. Eventually this would turn into, pretty complicated, it would turn into r squared. If I did FOIL and everything, we'd end up with this, cosine squared theta plus sine squared theta. This would be the rest of it. And then what works out nicely is this turns into 1 because of an identity. And we get r squared is equal to 4r sine theta. And we divide both sides by r to get r equals 4 sine theta. So we could go in the other direction for that also. A pretty complicated thing to do is to start with the with this graph. So all we have is this graph. And from this, we want to actually come up with the equation. Let me erase this for a sec, clear this out. I'm going to draw the circle a little bit bigger. But I'm going to pretend this point's over here, that the radius of this that this point here is 4, 90 degrees. And we know this thing's a circle. So if I wanted to just from the circle create this equation, the trick is I pick a random point on it and call it r theta. Then if I draw this line, this would be r, and this would be theta. Now I need preferably a right triangle that has r and theta in it. And the sneaky trick is right here. If I draw this diameter, which I know is 4, and I draw this line, there's a rule that inscribed angle in a semicircle is always a right angle. So now I have a right triangle. It's got r in it. It's got 4 in it. But where's theta? Well, theta is supplementary to this green angle. Sorry, it's complementary because a tangent line. This is this tangent to the circle. And this angle up here is also complementary. So theta is up there because there's a right triangle here. So using this triangle here, this one, I can say 4 is the hypotenuse, r is the opposite. So I can say sine theta equals r over 4, or r equals 4 sine theta. So that's pretty hard, the whole random r theta point, and then finds a triangle that has them both in it. But that's how that works. We can do the same kind of thing if the circle center is on the theta equals 0, or like the x-axis. So the trick would be to call this random point r comma theta, draw this line, that's r. That's not r. This would be r. And this would be theta. Actually, it looks like this one's a little bit easier. We should have done that one first. So we have this triangle here, and we can say 4 is adjacent, so cosine theta equals 4 over r, or r equals 4 cosine theta. So if you see something in this form, r equals something cosine theta, it's going to be a circle with diameter 4, who goes through 0, 0, and whose center is on the x-axis. But if it was, compare that to r equals 4 sine theta, that's one where the center is on the theta equals 90, or like the y-axis. The last shape I want to show you, this one's pretty complicated. This is a circle that's not centered at 0, 0. You have to be told the center. So let's say it's over here at 4, 30 degrees. And I know that the radius is 3. Now this seems pretty hard. When the center was at 0, 0, it was real easy. But when the center is not at 0, 0, so let's just make a note. The radius, not r, but radius equals 3. So the trick to this question is to pick a random point on the circle. You know, I think I would like to make this thing larger. Let's see if I'm able to. There we go. So we have 1, 2, 3. There's the 4, 30 degrees. Here's the circle. I'll just go like that. So what the trick is call a random point on the circle r, theta. Then this line from 0, 0 to that would have length r. And I'm going to draw to the center. We know that the radius is 3 because it's kind of like told to us. So that would make this line segment length 3, just like any line segment from the center to the circumference is going to be 3. And if I draw one more from 0, 0 to 430, well, I would know that the length of that line segment is 4. So this is pretty good. I have this triangle with r. It's an obtuse triangle with r and 3 and 4. Now we just need to get theta into the picture. Well, theta is from here to here, but it's known that from here to here is 30. That makes this little angle, the other angle of the triangle, theta minus 30. So if I draw this triangle kind of separate from this thing, it would have 4, 3, r, and theta minus 30. So the equation would use the law of cosines. It's going to be a pretty ugly equation. It would be r squared. This is if you know 3 sides, or if 3 sides are being used and an angle. We say, it would be 3 squared, side opposite the angle, is equal to a squared plus b squared minus 2 times a times b times cosine theta minus 30. And we actually can't simplify this very much more. All I could really do is bring everything over to one side. So I would get 0 equals r squared minus 8r cosine theta minus 30. This is 16 and that's 9, so plus 7. Okay, so what we've done in this video is we've seen three new configurations. A circle with center not at 0, 0, and the radius is known. A line that doesn't go through 0, 0, but the point closest to the 0, 0 is known. A circle that passes through 0, 0, and whose center is on the x-axis. And a circle whose center is on the y-axis and passes through 0, 0. So that's four more things to add to the, I think, four from the day before. A circle with center 0, 0, a horizontal line, a vertical line, and a line through 0, 0. So there's a total now of eight different shapes that we can graph or find the equation from the graph, that sort of thing.